Okay, so we've got a bullet. We're going to fire it from the surface with that speed, right? 2.3 gram. And we want to know what speed, and I think we're going to get an answer that's slightly off of this, so let's not worry about it. It'll be around that, because I think I rounded this value of the radius. So we are firing it from this surface with that speed, right? And we want to know not how high it goes, but how fast is it going when it's 100 kilometers above the surface. Okay, so that's like here. It's moving along, and I'll draw a picture of that. Hey, there it is. What is its velocity there? Because we know it goes 534 kilometers above the surface. So at 100 kilometers, it's still moving, right? So V equals question mark. So what we have literally is we've got kinetic and potential equals kinetic and potential, right? So we've got minus G big M little m. So I'll make this big M like the mass little m, right? Over, I'll call this R1. And then this distance here, we'll call this R2. Okay, so over R1 plus 1/2 little m V1 squared, right, is going to equal the opposite of G big M little m over R2. That's the, when it's up there 100 kilometers up, right? Plus 1/2 little m V2 squared. And we're solving, I guess, for this, right? All right, this is going to be fun. Okay. Oh, notice that the little m cancels. So the mass of the bullet in these problems doesn't matter, which kind of makes sense, I guess, right? Because a bigger bullet would have more kinetic energy, but it would also take more work to lift it up. So, okay, so let's see, minus 6.67 e minus 11 times 7.35 e22 over, and then we start from the surface, which is this, right? So 1.74 E6 plus 1/2, and then the mass isn't there, so it's 1150 squared, right, is going to equal the opposite of 6.67 times 7.35, 22, all over, I guess, 100 kilometers. Oh boy, this is going to be, I figured that out. Okay, so what is 1.74 times 10 to the 6th plus 100 times 10 to the 3rd? Because that's kilometers, that's thousands, right? We got to figure that out. 1.74 E6 plus 100 E3. This is equal to 1.84 times 10 to the, I could have figured that out without a calculator, couldn't I? 6 meters, right? So that is my new R. I can't put the 100 in because that's not how far I am from the center of the planet. I've got to figure out how far I am from the surface, right? So what I'm saying is that R2 is R1 plus 100. It's the radius of the planet plus 100 kilometers because we're above the surface, right? Okay, so this is 1.84 E6, and then we've got plus 1/2 V2 squared, right? So we're solving for that V2. All right, I can do this. Okay, so what I'm going to do is I'm going to go this whole thing minus this term here, and I'll have 1/2 V2 squared. Here we go. Opposite of 6.67 E minus times 7.35 E22 divided by 1.74 E6 plus 0.5 times 1150 squared. Just got an answer. I got negative 2156250. All right, now I'm going to subtract that term, this term right here. Subtract this term from it, right? So minus negative 6.67 E minus, notice we're subtracting it, we're really adding it, right? Times 7.35 E22 divided by 1.84 E 6. All right, did I get something? Ooh, I've got something. I've got a positive number, which is, this is always a good sign, right? When you're solving for something that you have to square root. So I've got 508,125 is 1/2 V2 squared, right? So multiply by 2 take the square root, and I got 1,008. Okay, so V2 is 1,008 meters per second. So interestingly, I guess it makes sense, right? Because the thing's going to go 534 kilometers up there. When it's gone 100 kilometers, it hasn't slowed down that much. Still zipping, still pretty zippy. Would still hurt. All right. That dog will hunt, I hope.